I have handed out your pink handouts, and we're going to do a little practice with them. And so as we go along, we're going to do a few calculations, and we're going to build up most of our motor block, time allowing. And we've picked some numbers. We've picked 1 horsepower, 20 horsepower, 75 horsepower, and 125 horsepower. We're going to refer to these as motor 1, motor 2, motor 3, and motor 4, going from the left to the right. So we're going to first pick this right out of your code book. So open your code book. Now, we already went to the code book to 432.50 and found the full load amperages. And what we find down below at the bottom is that we have actual nameplate ampacities and our service factor. So down on motor number 1, our nameplate is actually 1.9 amps and the service factor is 1.15. But remember, that only applies to the motor overload selection. Everything else, we're going to use the codebook ampacity. So if we're going to find the wires for number 1 and the fuses and everything else, we're going to base that off what? 2.1 amps or 1.9 amps? We're going to base everything off 2.1 except our motor overload heaters. So to find our minimum ampacity of our conductors for this motor, we're going to take 2.1 times 1.25, and we're going to find that we're going to have, again, all right, so we have 2.65 amps, 6.625, 2 1/8 amps is our minimum ampacity for the conductors. And we're going to go to the second and we're going to multiply 27 times 1.25 and we're going to find that it's 33.75 amps. We're going to do the same thing with the 75 horsepower. We're going to take 96 times 1.25. We're going to find that that's 120 amps. And for the final motor, we're going to find 156 amps times 1.25 is 195 amps. All right, so everybody's okay with our minimum ampacity, right? So let's select some wires. So let's go to 31016. I'm going to hit a pause while we find that in our code book. All right, so we're going to find our wire size. And of course, the first one is going to be number 14. Now, we're going to assume that our equipment has no terminal markings. All right, so that means that we have, for our first motor, we're going to have to select the far left column. So we're going to go number 14, which in this case is good for 15 amps. So we plug that in, and we're going to plug in number 14 at 15 amps. Now our next motor, we have a minimum of 33.75 amps. And if we go down the far left column, we can see that a number 10 is good for 30 amps, but that's not good enough. It's 3 amps short, so we've got to go to the next larger size wire. So we've got to go to number 8. So we're going to go to number 8, which is good for 40 amps. I'm going to plug that information in. Then we're going to go to the next one, and we're going to see that we need 120 amps. Now, this time, we don't have to go to the far left column. Because it's over 100 amps, we can go to the center column. So we're going to go to the center column, and we're going to find one that is more than 120 amps. Now, we can't use number 2 because it's only 115. So we've got to go up to number 1, which is 130 amps. So we're going to use number 1, at 130 amps. And the last one, 195 amps, again, we're not going to have to use the far left column because it's over 100 amps. We're going to use the middle column, the 75-degree column, and we need at least 195 amps. And so we're going to have to go down to 3/0, which is good for 200 amps. Okay, so now we've selected the motor branch circuit conductors, and we've selected the actual wires, actual wire size, and now we could select the conduit size. But we're going to skip that step today. We're going to go up and we're going to size our motor starters. Now, where can we find our motor starter? If you look at the front page of your handout, it has a motor starter selection guide. Now, this is not the exact chart that we're used to looking at. This is not the square D chart, but they're all more or less the same. They have the same numbers in them anyway. But we need a how many horsepower motor starter? It's a 1 horsepower motor starter. So if we have, and this is a 3-phase chart only, and we can see that the full voltage starting is always an indicator, so we have to go to 460, and a double-aught starter will go up to 2 horsepower. Can everybody see that? Okay, I know this is not the normal chart you're used to looking at, but that's okay. Actually, the one that's in front of you, the pink one, is much easier to look at, right? All right, so our first starter is going to be a double-aught. Okay, let's go to our next starter. And our next starter, according to our chart, should be what size? It's a 20 horsepower. Let's go back to that chart. And we can see that at 460, if we need to go up to 20 horsepower, we're going to need a size number 2. And because a number 2 will go up to 25 horsepower. Let's see. So we're going to put in a number 2 motor starter there. And then our third one is a 75 horsepower, again at 460. So let's look at our chart. And 75 horsepower at 460, we've got to go up to a number 4. Everybody agree with that? Okay. So let's put in a number 4 here. And then our last one is 125 horsepower. That's a very large motor, for those who are wondering. It's a huge motor. Okay. And let's go back to our chart and select the correct motor starter. And once again, we're on 460 volt, full voltage starting. And it's 125 horsepower, so a number 4 will not do because that'll only go up to 100 horsepower. But a number 5 will go up to 200 horsepower, so we're going to select number 5. Is that correct? All right, let's select a number 5. Okay. Now, before we go on any farther, one of the things we want to remember how to do is if we want to select the feeder circuit that's going to come to this motor block, we would select the largest motor and multiply that FLA times 125% and then add all the other FLAs for our feeder circuit. So we're going to add 195 amps plus 96 plus 27 plus 21. So our total would be 320.1 amps. So we want an overcurrent protection device that's going to be larger than 320, and we want wire that will carry 125% of 320.1, right? Okay, so we need at least a 400.125 amp wire. And so we know that we could use a 600 kc mil wire at 75 degrees. It's good for 420 amps. So that's more than enough, slightly. And so therefore, we would want to have a circuit breaker that's slightly larger than 320. If we go to 240.6, what circuit breaker might we feed this whole load with? Go to 240.6 real quick, and you find the standard fuse and circuit breakers, and there is one that is 350 amps. So we could use a 350 amp circuit breaker or fuse to feed the circuit, and we could use a number 600, not number, but 600 kc mil wire to feed this thing. So now let's assume that we know that we have 3 600 kc mil wires coming into, we're going to assume we know that we have 3 600 kc mil conductors as our feeder. And that's going to affect the size of our auxiliary gutter, right? Okay, so now let's go back to our starters. And one of the main things we want to do now that we have our little pink handout is to select the overload heaters. Let's start out with our first motor. And our first motor is only 1 horsepower. And it's in a double-aught starter. And so we're going to look at, we're using 8536 starters. And so if we're using a double-aught, in the odd case of the 8536, look at this asterisk here. Oh, that's 8904. And this, I'm assuming, is the large. Let me make sure I'm in the right one. Yeah, we're in large enclosures, not small enclosures. And unless otherwise stated, we're going to use large enclosures. Small enclosures are when you have a space problem. And we're using, you know what, I think I'm on the wrong page. Okay, now what it means that if we're using 8536, we're using what's called a motor control center. In other words, there's a square bucket that fits in this thing that takes the breaker and the starter and all that good stuff. You know what? Let's not do that. I don't want to use a motor control center yet because that would mean we would be using instant trip circuit breakers. That would be changing completely what I had in mind. So we're going to go down and we're going to use an 85, let's use an 8606 starter. That's an open type starter that comes in a box. And so we're going to use an 8606. Now, if we're using an 8606, notice that for a double-aught, there are 2 different starters you could use. But the top one is 8536 only. That's only for motor starter buckets. Okay, so we're going to use the one below that that says type SA, series AB, double-aught. Now we need to go to page 53 or table 53 to select the overload thermal unit. So let's go to that page. Okay, so we're going to go over to table 54. And since it's 3-phase, we're going to select 3 thermal units. So on table 54, 3 thermal units, and it's only, it's got to be the wrong one. Oh, 53, I'm sorry. I could tell from just some of the numbers on table 54, that was wrong. Let's go back over to table 53. And what was our full load amperage of our motor? It was 1.9, right? Let's go back to our chart. 1.9 is our nameplate ampacity. And it's a service factor of what? 1.15. So we can use the full 1.9. So we're going to just look up 1.9 in here on table 53. And you can see that that is the third block down where it says 1.07 to 1.18. So we would use a B 1.67. Does everybody see that and agree with that? Does anybody agree with that? Okay, so my mistake. We would be down at 1.9, which is down here between 1.84 and 2.04, and that's overload heater B300. Okay, B300. So if you're using that, that will keep you safe. Now, let's go back to our other chart. And let's go to our next motor at 20 horsepower. And if we look at our chart, okay, so for our second motor, our 20 horsepower motor, the full load ampacity is 27 amps. But our actual nameplate ampacity is only 25. So we're going to multiply that times 0.9 and find that our ampacity is actually 22.5 amps. That's the overload heater we want to look up, because we want to take the nameplate ampacity, which is 25 amps, and multiply that. Because it's a service factor 1, we're going to multiply that times 0.9, which is 22.5 amps. So let's go back to our chart and find out what, or back to our pink handout and find out which chart we've got to go to. So we're using an 8606 starter still. And what size starter was this one? Is this number 2? Guess we need to look. Number 2, okay. So we're going to find a number 2 starter here. We're going to go to chart 58. Everybody see that? So now we're going to go to chart 58. Okay, so now we found chart 58. That is the right chart, right? Everybody agree with that? Okay, and what was the ampacity we need to look for? 22.5. 3 thermal units, 22.5 is between 20.3 and 22.8. Everybody agree with that? So we're going to select this one right here. Right? So that's B36. Not 3.6, but B36. Okay, so now we're back to, so we've found B36 to be our overload heater for here. So now we're going to look at the 75 horsepower, and notice that it's a service factor 1.0 also. So its full load ampacity is 96 amps, but its nameplate ampacity is only 85 amps, meaning it's a fairly efficient motor. So we're going to take 85 amps again, and we're going to multiply that times 0.9 because it's a service factor 1 motor. That means we can't overload it at all. So at 76.5 amps, that's where we want it to stop heating. So let's go back to our chart and find our, or at least go back to our guide and find the right chart to go to first. All right, now this time we're using what size starter? We're using a number 4 starter. So we're going to come across over here to a number 4 starter, which is chart number 61. Now let's go to chart 61. And what ampacity are we looking for? 76.5, right? All right, here we are at table 61. And we want to find 76.5 amps. And with 3 thermal units, 76.5 is going to be right in between 71.5 and 77. Everybody agree with that? Okay, so we're looking at CC 103. Anybody want to agree with that? I think that's correct. CC 103. So let's go back and put that in our motor block. We're going to add CC103 right here. Okay. And now we're going to go find our last one, and it is a service 1.15 motor, so we don't have to multiply the nameplate ampacity times 0.9. We just take the full motor load nameplate ampacity of 140 amps, and we just look that up. But so where are we going to go to look? We're going to go back to our chart. Okay, so we're going to go to our chart again and find that our chart, our size 5 starter is going to be table 24. So let's go to table 24 now. All right, so we're at table 24 now. And I guess it doesn't have 1 or 2 thermal units. So table 24 at 140 amps is going to be in between 132 and 149. So we believe that's going to be a DD160. Is that correct? DD160. I'm asking. Look at the chart. Okay, so we want a DD160. So now we have selected all the motor starters and the overload heaters to go in them. Okay. Now let's go a little farther and let's do our next one, which would be our circuit breakers or fuses to feed this, because we have an odd one that's kind of small and we might be able to use an odd. We're going to use dual element time delay fuses, and also we're going to look at the last 2 pages of our handout to find what size switch does that indicate. So if we're looking at this first one, our full load ampacity is only 2.1 amps, right? So even though we're using 175% for our fuse, we're going to have a fairly small number. So 1.75 times 2.1, we'd only get, 2.1 times 1.75 is 3.675 amps, right? And that's not an exact fuse, is it? Now we're going to go over to 240.6 to find what size fuse we could possibly use for this, and we know that we can go up slightly, right? Let's go to 240.6. Now our standard breakers and fuses start at 15 amps, but if we look at the oddballs that only come in fuses, we could use one of those oddball fuses, couldn't we? It says they come in 1, 3, 6, and 10. Now 3 is just a little too small, and we don't want to allow that. So in this case, we could use a number 6, a 6 amp fuse, right? Everybody agree with that? Okay, now let's look at our next one. And our full load ampacity is 27 amps. We're going to multiply that times 1.75, and that is 47.25. And I don't even have to look too far. I know that that's going to be a 50 amp breaker, right? Because there's no 47, 48, 49. So we know that this fuse right here is going to be a 50 amp fuse, right? So we're going to use a 50 amp fuse here. Move this down a little bit. Okay. Now on our next one, okay, so our next motor number 3, the 75 horsepower, draws 96 amps full load ampacity, and we're going to multiply that times 1.75 to find 168 amps. And if we look in the fuses, there is no 168, not too surprising, but there is a 175. So we're going to have to use a 175 amp fuse. Why is it not working? Right? Okay, now our final one is going to be kind of a big one, right? We're going to have 156 amps times 1.75, and that's 273 amps. Now look at our fuses, and I'm guessing we're going to have to go up, yep, sure enough, to 300 amps. So let's put in a 300 amp fuse in here. Now, the reason we wanted to do that is because we now want to be able to select our actual safety switch, our fused disconnect. So let's go to the back couple of pages, and you'll find that they come in two voltages, but that doesn't matter. They have the exact same sizes, whether they're 300 or 600 volts starters, or I mean disconnects. So we can just look at this, and we know that this is 3-blade, 3-phase, 3-blade, right? 3-wire, 3-blade fuse holder. And look at the chart, and it's very simple. It goes 30, 60, 100, 30, 60, 100, 200, 400, 600, 800, and there is no 1,000. Okay? There's a oddity there that you need to remember. 30, 60, and you're thinking 100, but it's actually, it is 100. 30, 60, 100. So that's okay. But when we go up 100, 200, 400, 600, 800, you're thinking there ought to be 1,000 there, but there isn't. And it goes up to 1,200. Okay, and you got to kind of remember that, because that could save you a step of having to go back and look. And saving time is sometimes fairly important. Now let's look at the very first one. What size, even though we've got 6 amp fuses, what size safety switch have we got to put in? Fuse disconnect. 30 amp. That's a 30 amp, right? Now we have in the next one a 50 amp fuse, but you'll notice there's no 50 amp safety switch, fuse disconnect. So we're going to have to go up to 60 amp. So in this one, the second motor, we're going to have a 60 amp. Why is it not doing anything? And I'm going to say 60 amp switch, if that's okay with everybody. All right. And then our next one, we have a 175 amp fuse. Sorry, 175 amp fuse, right? So struggling with the presentation software here. Sorry. Okay. So on the one where we have a 175 amp fuse, what switch are we going to have to stick those 175 amp fuses in? 200 amp switch. Okay, and the final one, we have some big fuses, 100 and, no, 300 amp fuses, right? Is there a 300 amp safety switch? You would think there would be, but there isn't. We have to go all the way up to 400. So now we have selected the motor starters, the starter heaters, the fuses, and the fused disconnects. And the next step, of course, would be to find the tap conductors and then the auxiliary gutter that it would take to do that. But we don't have enough time to do that today because this has been a little time consuming, so we'll do that. But you guys already know how to do that from previous presentations, right? Okay, good. All right, so we're going to call that a day. Thank you very much.